That's me. You know what? The Twitch app's getting slightly better. Maybe. Don't make me take that back, Twitch app. I'm taking it back. Twitch app's just the same as it was previously. Hey everyone. I want to give a quick shout out at the start of this video while you're all still actually paying attention to the fact that you have a blank screen again and it's Monday again and you're watching the boringest stream on Twitch, a man trying to learn C++. And I want to give a shout out to like the two people who religiously come to my YouTube and like and watch my C++ and my Unreal Engine stuff. Like I don't know if it's the same two people. It could be like a different two people each time. It could be the same person. It could be the same person with multiple accounts. It could be a horde, a weird secret BBS thread on the dark net that I do not know about, who have decided to pit their lives upvoting these weird videos made by this one guy. But thank you, you weirdos. Go watch some interesting content, man. What the hell? Anyway, with that out the way, we can continue to not learn C++. Last week we did algebra, I think, the order of operations, and precedence, whatever it's called. How different things in functions and algebra in your code will fire off if you leave them unbounded by parentheses. And as I said multiple times in the last stream, why not just use some parentheses, bro? They're right there. Just press Shift 9, and then I'm in the wrong zone. I'm not typing. Oh my goodness gracious me. So I've got this USB wireless keyboard right here. It's okay. Someone said it was broken. Works fine. Does need a cleaning though. It's kind of disgusting. Welcome to the Mathmo stream. Today. All right. Okay. So we've got a graph. We've got a table listed in there. Groups the operators by their precedence. The unary arithmetic operators have higher precedence than the multiplication and division operators, which in turn have higher precedence than the binary addition and subtraction operators. Operators with highest precedence group more tightly. Operators of higher more tightly than do what? Operators of higher precedence group more tightly than do operators with lower precedence. So we have our BODMAS at the bottom of the table. Of course, you can ignore the B of the BODMAS and the O, in fact, because the O is actually just a subset of the D of the M, I guess, in theory. But above those, in front of BODMAS, we have unary. Operators. Unary plus and unary minus. And I don't want to take a wild stab in the dark and say that those are, for example, plus equals or what's the other thing? Increment, because that would be a different operator. That would be a plus equals or a plus plus. But a unary operator is an operator which only has one thing in, which I can understand unary minus. That is itself just, you know, assigned int, right? Assigned int, assigned float, assigned value. Unary plus, not so clear. Maybe you could go into that. Maybe you could tell me, what is a unary plus? Because I don't know. Arithmetic operation behind any of the arithmetic, blah blah blah, blah blah blah. Operands, the result of the operators are R values, blah blah, R values and L values, right? Which are weird. Unary plus operator Ah, here we go. And the addition and subtraction options may also be applied to pointers. Okay. Covered the use of binary plus or minus of pointer operands and applied to a pointer arithmetic. A unary plus returns a possibly promoted copy of the value of its operand. Your what? Unary minus operator returns the result of negating a possibly promoted copy of the value of its operand. Yeah, okay, yeah, so, yeah, okay. So, it is exactly as I just thought, considered, predicted, maybe. If you do a type assignment, if you do a value assignment, sorry, of a thing and then a thing. So if you have, for example, in the book, it has an int type, an int value assignment here. We're initializing two ints. We're setting one of the initializations to a number, and then we're initializing the second int from negative the first int. That has a higher precedence than an addition or a subtraction, and using the negative sign returns a negative copy of whatever you had. So exactly as I said, it changes the sign, makes it a signy boy, and it does the thing. Same with the plus, except it does it with the plus, which is usually implicitly kind of described by any kind of non-negative value assignment, right? That's maths, bro. That's how it works. Good, love it. Noted that bool values should not be used for computation. The result of negative bool is a good example of what we had in mind. Bools are promoted to int in this case. Value of b is true, which promotes the int value 1. Yeah. Promoted value is negated, yielding negative 1. The value negative 1 is converted back to a bool and used to initialize b2. Initializer is a non-zero value, which when converted to a bool is true. Yes, correct. Bools are non-zero values, if they're true. They can be negative and they can be positive. But the only bool that's false is 0. It's fine. As long as you understand that concept, you can do whatever you want with a bool. Do what you like. So it says it can convert a bool into an int, and when it converts a true bool into an int, you get one. I guess maybe there'd be a little bit of a hiccup. Maybe it would question your motives in the compilation stages about having a negative value as a bool. But no one really cares, I guess. We'll cross that bridge when we come to it, and you know, I don't think we'll ever have to come to it. Really, we have we have a grasp. We have a grasp. When it comes to objects of arithmetic types, arithmetic operators plus minus, multiplication, division, for obvious meanings, addition, subtraction, multiplication, division, blah. Division between integers, return integers. If the quotient contains a fractional part, it is truncated towards 0. You get that? So it's truncated, it's not rounded. Understand that if you get a value of 16.99 out of your integer or int and float division sequence, it will be the 99 will not increase the value of the base int. It will simply be cut off. Which is why if you're doing any kind of weird stuff with numbers that require multiplication, division, addition, or subtraction in large quantities that aren't just increments, you should use floats, because then you can have a control over the precision of the decimalization of your stuff. That's where my hard-boiled DVD went. So I have so many, going off on a tangent there. I was looking for a couple of these quote-unquote classic Kung Fu DVDs. They're all, they're under my speakers. What is that? It's like, I've seen all these films before, that's why I use them. Oh, it's Guardians of the Galaxy. Huh, interesting. Yeah, I didn't have any... so I don't have enough space to put my speakers the right way up and then be able to access the controls, because there's like... I don't want to even describe the situation which is on this desk right now. It's a horrible mess, but yeah. So I had to make some risers for my speakers, but I didn't have any material or really the want to make risers myself out of like scrap wood or anything like that, because it means making a box, and it means having everything the same length. Last time I made a box, it went horribly wrong. It's not actually square, and I what are you gonna do? But then I thought, oh well, I've got 12, 14 kung fu films that I've already watched. Let's just use those, and so there you go. My risers for my speakers are made out of DVD cases. The percent operator modulus. The remainder of modulus operator computes the remainder that results from dividing the left-hand operand by the right-hand operand. The operands to modulus must have an integral type. Must have integral type. Must have what? Okay. Oh, right, okay, they must be the same. So you got to use ints, right? Huh. Earlier implementations allowed dividing by negative numbers, but now oh, right, okay. No, ignore that. So it's fine. You can do whatever you like, but it's going to round. What? Why would it round? Implementation of a negative m divided by n, part of the modulo function. Let me actually read this. Hold on. Modulus operator is defined so that m and n are integers and n is non-zero, then m divided by n times n is plus m modulo n is equal to m. Okay. So that's saying so that's m is equal to m divided by n times n, and then added the remainder back on, because there'd be a truncation if it was an int, and these are all int options. Okay, because it's dealing with rounding and truncation. Previously, before that, it would have been false to assume that, because there were certain cases where it would round away from 0, so it would round up rather than down, which is not allowed in the case of truncating decimals off the end of integers, and especially not allowed in the case of modulo, because there shouldn't be any. Ooh, parenthesize the following expression to show how it is evaluated. Test your answer by compiling an expression without parentheses and printing the result. Cool. So we'll type it out and then we'll do it. This is the bit where I've typed it out wrong. Didn't actually mention modulo as a thing. But modulo is a function, right? So I'm guessing it's going to be a higher precedent than can we just so we will know instantly if we are right or wrong when we do this. I suppose we got to do this something. Put the whole thing in a parenth. So what we got? We got 12 divided by 3 times 4 plus 5 times 15 plus 24 modulo 4 divided by 2. So the modulo is a function that will return the remainder of a division. Okay, 24 goes into 4 exactly 6 times, so it will return 0. And it's a function. I want to put that in parentheses. 0 divided by 2 is 0 plus 0. It seems like it's wrong, but I mean it'd be the same value anyway if it was modulo 2, so it'd still be 0. So like this, and then like this, times 15. 12 divided by 3 times 4. Ah, yeah, here we go. Here's an example of where division and multiplication would actually clash, right? 12 divided by 3 times 4. So it's either 4 times 4, right, or 1. It's either 16 or 1. And brackets order, division, multiplication, addition, subtraction. It is. And if we work it out in our brainy boys, thank you for telling me for the 900th time that I have an update available to install. Thank you. It's fine. I'll do it later. We need an end line here. That doesn't look like it's gonna work. Nothing got highlighted, and nothing got fucking tabbed. Jesus, what's wrong with you? Yes! Who's your daddy? I guess we gotta title this. I'm using the wrong goddamn keyboard. Yeah. Feel the power of me slamming my armrests down. What is this? Lol. That's what it is. So this keyboard has a function key as well. Strangely, it's right next to the Windows key. What's going on there? Okay, so the Windows key is one further over. Okay, that's kind of nice. That'd stop you like window keying out from games and apps and stuff. It's just kind of cool. But yeah, this is a disgusting keyboard, and I kind of regret picking it up to use right now. It's cool that it's wireless though, so I can have it on my lap, so I'm not destroying my back, you know, because I have my my clicky boy, set up for quote unquote FPS game. So it's, you know, it's at an angle, like the numpad is like center of mass to me. It's like it's way off. I'm really tempted to get like one of those just a one-hand keyboard, like the Razer Orb Weaver or something like that. You know, 3 or 4 lines of, you know, FPS game. It'd save a lot of space on this desk, and I can have the wireless keyboard for doing actual typing. Who knows? That's probably a bad idea. And there's probably a game that I play that would determine the result of the following expressions: -30 times by 3 plus 21 divided by 5. Okay, so -30 times 3 is -90 plus 21 divided by 5, which is 4. -90 plus 4 is 86. -30 plus 3 times by 21 divided by 5. As we know, BODMAS, division happens before multiplication, so we have 4 times 3 is 12, and minus 30, which is minus 18. 30 divided by 3 times 21 modulo 5. So we have 30 divided by 3 times 1, which is the modulo of 21 and 5, which is 3. 30 divided by 3 is 10. And -30 divided by 3 times 21 modulo 4, it's still 1, it's still 3, it's -30 divided by 3 is -10, surely. Write an expression to determine whether an int value is even or odd. Ah, I fucking hate this. This is like... Is this even right? Is that right? I get the feeling that's wrong. We got the stuff for that right here, right? We got strings to wagwan for auto C, auto C is punct. C out. There's no C in there at all. Lied to me. cn data.upc data1.quantity price data1.total equals data. Where's the I swear we did a whole bunch of, you know, while cn equals. All right, here we go. String word while cn word whoop case. Okay. So int v while cn v. Did we need a... Go home, Visual Studio, you're drunk. Int v while cn is v. In fact, yeah, what the hell? What the hell's going on here? This should all be back. It should all be back here. While cn is v, if v modulo 2 is equal to 0, do I need a semicolon there? Print f. See out. Even dog. It's a string literal. Yeah, I know. I put, yeah, fuck off. Don't even talk to me about that. I know you're trying to help Visual Studio. Break. Else. Odd dog. Build errors. No. What do you mean build errors? My C is infallible. How dare you? What do you mean fail? What do you mean errors? Expected a semicolon. Syntax error missing semicolon. $268. I'm so sorry. I am so sorry. Aha, yes. 3, odd dog. It's beautiful. And then 2, even dog. See, it's beautiful. It works fine. I don't know. You gotta stop. Yeah, I'm sure there's a smaller way of writing that. Like, but yeah, we did that. That's cool. Been going for 22 minutes. That's not that long. We can keep going. We are going on to logical and relational operators. The relational operators take operands of arithmetic pointer type. Logical operands take operands of any type that can be converted to bool. This operators all return type of bool arithmetic pointer to operands with the values 0 or false. Other all values are true. Operands to these operator values are our values, and the result is an R value. Okay. Alright, logical operators. Not less than or equal to, greater than or equal to, equality, inequality, logical and, logical or. Okay, so we and ors, ifs, whiles, equality. We've done a lot of this already. It makes sense. The right-hand side of an and is only evaluated if the left-hand side is true, and the right-hand side of an or is only evaluated if the left-hand side is false. So if you want your code to be ultra fast, you want to put the most likely to fail in the left-hand side of an and most likely to succeed in the left hand of an or. I guess it doesn't really matter. It's like one extra cycle for each of those, right? Big sip. It's a lot of talking, you know. It's a lot of rambling. And it's a lot of going insane. Note S as a reference. Oh, so you can use the not. You can use the logical not operator on an expression as well. Usually, we've seen it previously as like the inequality. So it modifies the right-hand side of itself. So the inequality is a not and then an equal to. But it's actually not. It's a different thing because it's not an equality sign. It's an equals to. It's an stupid. I guess it saves you a keystroke, but it has to be like set separately. But I guess it's kind of visually the same thing, even if it's not actually logically the same thing. But it is actually the same thing, but it's separate because it's different. Exclamation marks make things upside down, okay? Just know that. Just know that, okay? After we print the current element, check to see if we need to print a new line. Okay, what? I've skipped some space thanks to the horrible scrolling on this horrible smartphone. Sorry, it's just old. It doesn't understand what smooth scrolling is. Like, you flick a screen and then you're 100 pages downwind. You don't know what's happened. Index does not equal s.size and does not space is space s index. Okay. Why you gotta make it so cryptic? Why you gotta be like this? First checks that the index has not reached the end of its associated string, yes. We're guaranteed that the right operand won't be evaluated unless index is in range. Cool. As an example, use logic. Or imagine we have some text in a vector of strings. We'll put the strings, adding a new line after each empty string. We'll put, or after a string that ends with a period, we'll use a range-based for loop to process each element. Okay, that's fine. For example, and then there's an example. If cout s, if s.empty or s brackets s.size -1 is equal to full stop, cout end line, else cout space. Blank lines and those that end with a period get a new line. Everything else gets a space. That's cool. That's kind of cool. I think I may have accidentally breezed too hard over the C++ string functions. Might have to go back to those one day. Not the C string functions, the C++ ones. Logical operator returns the inverse of the truth value of its operand. We first use this operator in 3.2, apparently, page 87, if you're following along in the book. C++ primer, volume 5, edition 5. Volume 1, edition 5. There is only one volume. It is one book, but it's edition 5. Assuming vec is a vector of ints, might use the logical not operator to see whether vec has elements by negating the value returned by empty. Print the first element if vec, if there is one. If not vec.empty, cout vec 0. Huh, cool. The sub-expression not vec.empty evaluates true if the call to empty returns false. That's interesting. That's good. And we use that a lot. We use the not operator a lot in the Epic Games Unreal Engine. Absolutely we do. Speaking of which, I went onto the Discord forum, I asked my question, and we have a small result. Not a direct result, but a linked result, which is much nicer, I think, actually, because it doesn't require someone to take hours out of their day to explain to some noob on the internet how to actually use the Unreal Engine. We have a thing for our problem. We will look at that later. Relational operators less than equal to, greater than equal to have ordinary meanings, return bool values. These operators are left associative because relationship blah, 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 blah. Because the relational operators return bools, the result of chaining these operators together is likely to be surprising. Oops! This condition compares k to the bool result of I less than j. Oh. True if k is greater than 1. Okay, so don't string them together. Or do, if you know what you're doing. I guess if you're going to evaluate it, they go from the left to the right. So if they're evaluating left to right, you have left things that you want to evaluate as a bool. And if you want to find out something, maybe if it is a bool, maybe if the variable is already going to be a bool type input, you could use that to compare a bool to previously uncompared bool result thing. It's cool, right? Equality tests and the bool literals. Test the truth of most direct ways to use the value as a condition. If value, true if any value is non-zero. If not value, true if any val is 0. Okay. Both conditions, compiler converts val to bool. First condition succeeds as long as the val is non-zero. Second condition succeeds if val is 0. Cool. That's fine. If val equals true, blah blah blah. If val equals 1, okay. If 1, welcome to the infinite zone. It's usually a bad idea to use Boolean literals true and false as operands in a comparison. These literals should be used only to compare an object of type bool. Good. Explain what operands are evaluated in the logical and logical OR and equality operators. Explain when operands are evaluated in the logical and logical OR and the logical equality operators. When you're using those operators, dude. I mean, look, these, hey. There you go. It's been evaluated. That's when. Explain the behavior of the condition in the following if. Const char star CP equals hello world if CP and star CP. So if CP it's a char pointer, constant char star CP is a pointer, is the value of a pointer. What? Explain the value of the condition in the following if. Explain the behavior of the condition in the following if. It's gonna compare the pointer and the value of the pointer, and if they both have a value in them, then it is true. So if there is a pointer and the pointer that the memory it points to has a non-zero value, which in this case it's hello world, that seems non-zero to me, it's probably going to evaluate to true. Write the condition for a while loop that would read ints from the standard input and stop when the value read is equal to 42. I actually know how to do that. We're going to use that same the vector pushback thing. We're going to do that. We're gonna do that. We're gonna, where is it? Vector 2. So yeah, while seeing we'll set up a vector of ints. And then you will have if the in is 42, break, else pushback, and then that'll just do the thing. I don't want to do it because I don't know. Vector vint I've got to do a thing, haven't I? I'm making a vector string. Do I need to put int in here? Do I need to do that? Vector int, yeah I do. Vector int vint while c in b if v is equal to 42, break, break else. Vent dot push back the you kidding me? Is that not how you do that? Oh, brackets. Okay. You happy now? There's a thing here, isn't there? Expected bracket. Okay. So we got to do the first odd dog, and then 1, 2, 5, 7, 9, 34, 42. End. So that's creating a vector. It's filling the vector with stuff. Don't know if the 42 gets printed actually. Interesting. Of course it doesn't. No, if v equals 42, it breaks. It doesn't get added to the vector, but it does stop the program. There you go. If you wanted the 42 to be saved into the vector, you could just add a pushback before the break, and that would be fine. Write an expression that tests 4 values a, b, c, and d, and it shows that a is greater than b, which is greater than c, which is greater than d. I'm not going to initialize 4 ints. But you would assumedly do it something like this. A is greater than b, which is greater than c, which is greater than d. If A and B greater than C and C greater than D, I'm using the wrong goddamn keyboard. I'm reaching over, I'm skewing the back. I can feel it already. Did you hear that? Oh, that is not a friendly sound. Coders, anyone who does lots of typing, take care of your back. A equals 10. B equals 5. C equals 3. D equals 1. You did a win. It worked. Assuming I, j, and k are all ints, explain what I does not equal j is less than k means. Aha! This Does that even work? A is greater than B, and B is greater than C, and C is greater than D. I don't think that's actually good code. I think that probably is stupid. That probably doesn't work right, does it? So considering maybe if we like yeah, set that to C and set that to A, and then run it. Ooh, it does work. Okay. I just thought maybe because they were talking about a whole bunch of they scared me with the whole using a whole bunch of bool things together is bad, but actually the ands see even if this, so A is greater than B, bool 1, and B is greater than C, bool 1 and 1 and 1. So it's gonna evaluate if even if this is all bool, it's gonna evaluate bool 1 to bool 1, right? So as long as they're all bool, I guess that's fine. I hope. I does not equal J is less than K. I does not equal J is less than K. So this evaluates whether K is less than 1, because I does not, assuming they're all different ints, assuming that I does not equal J, if that is true, then it evaluates if K is greater than 1. I is, yeah, right, yeah. Left-hand operand assignment operator, there must be a modifiable value, for example, given. Constant ci equals I. Okay. Assignment operators. The left-hand operand of an assignment operator must be a modifiable I value. For example, given 1024 equals K. Wah, wah. Literals are R values. I plus J equals K. Arithmetic value expressions are R values. Ci equals K. Ci is a constant non-modifiable I value. Okay. It's getting warm in this room. I don't know why. PC is warm. Is it taking that much? Is it taking that much CPU to compile this? This is garbage code. Okay. And then you standard, we can use a braced initializer list on the right hand side. K equals braced 3.14. Error narrowing conversion. Vector int vi initially empty. Vi equals brackets 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 elements through 0 through 9. Okay, it's fine. Assignment I's right associative. Assignment is. The kerning on this fucking font, mate, makes my eyes bleed. Unlike the other binary operators, assignment is right associative. Int ival jval. Ival equals jval equals 0. So it sets jval to 0 first, and then it sets ival to jval. Okay, that's fine. That's cool. Because assignment is right associative, the rightmost assignment jval equals 0 is the right hand operand, leftmost assignment operator. Cool. Yeah, that's what I just said. Int ival star pval. Ival is an int, pval is appointed to an int. Ival equals pval equals 0. Cannot assign the value of a pointer to an int. No. String s1 s2. S1 equals S2 equals the string literal. Okay, that's fine. So you can't do the string assignment when the values are different. You'd have to do p-val equals 0 and i-val equals star p-val, right? You'd have to reference the value in p-val. Or you'd have to do i-val equals 0 star p-val equals 0. Oh, I can't remember. Is it star p-val to edit the information held within the pointer? Whatever. It does a thing. It does a thing. Either int I equals get value bracket, get the first value when I does not equal 42, do something. Hello. Oh. Assignment has low precedence. Uh-oh. Int I, while I equals get value, does not equal 42. Do something. Okay. So we could streamline that while seeing v equals 42 break. But then there'd be no option for accessing a function when it did hit 42. It would just stop. So, potato. Beware of confusing equality and assignment operators. Shut up, book. You bring this up every damn chapter, and every damn time I do it. Goddamn son of a bitch. You often apply an operator to an object and assign the results to the same object. As an example, consider the sum program from 142, page 13. Int sum equals 0. For int val equals 1, val is less than or equal to 10 plus val. Cool. I don't remember seeing that code, but that's friendly code that I like to see. This kind of operation is not common with not just with addition, but every other arithmetic operator and the bitwise operators, which we cover in 4.8, page 152. Compound assignments for each of those operators: plus equals, minus equals, times by equals, divide by equals, plus modulo equals. Less, no. Out equals? Less, no. What the fuck is that? Okay, these bitwise operators I have not seen, and I do not wish to see. Hello there, are you a beginner? Because I'm learning C++. Yes. Hello there, I am a beginner. I am also learning C++. Welcome to the Let's Learn C++ channel. It's not the only thing I do, but it is the only thing I do on Mondays. Just to make Mondays extra bad for everybody, you know. I'm kidding, C++ is fun, and everything within it is fun. What are the values of I and D after each assignment? Int I, double D. D equals I equals 3.5. I is 3, D is 3. I equals D equals 3.5. A double is a float value, right? So that's D is 3.5, probably 0.00000, and I is 3, still, because it's an int. Explain what happens in each of the if tests if 42 equals I. No. What? That's not equals, that's assignment. You flipping blimey. You can't do that. You can't do that. You've confused your assignment and your equals. You can't assign a variable value to an R value int literal, you fool. Your program crashes, doesn't compile, blah blah blah, etc. If I is 42, if I assignment 42, if you assign 42 to I, yes, it does the if loop. The following assignment is legal. Why? How would you correct. Double deval int ival int star pi. Dval equals ival equals pi equals 0. Yeah, okay. So oh, you read the C++ primer book. I do read the C++ primer book. I'm on 4.4 4.1 exercise 4.15 if you're interested in following along at home. And I guess we'll just blast through. I'm getting kind of uncomfortable. It's really warm in here for some reason, so I'm gonna have to stop soon because it's hard to breathe. Maybe I've just got the coronavirus. Who knows? So you can't assign an int literal to a pointer. So what you would have to do is dval equals ival equals 0 and then star pi equals 0. So you can assign the value to the thing that you're pointing to, or you could do you could put dval equals ival equals 0 and then pi equals ival maybe. What is my project? My project is the C++ primer book. I just want to learn some more C++ because I don't feel like if someone said to me dev a program, I'd turn around and I'd just uninstall myself from that company. You know what I'm saying? I want to kind of get to a point where I understand enough that if someone says do a thing, I can at least, you know, have an attempt at doing the thing, you know? Increment and decrement operators. It's really easy. Everyone knows what increment and decrement operators are. Plus plus. And minus minus. So j equals plus plus I, it will increment and then assign. J equals I plus plus will assign it to I, and then it will increment it. Oh, no. What? Int I equals 0, j. Oh, right, yeah. I is equal to 0 to begin with. So j equals plus plus I, j will equal 1, I will equal 1. J equals I plus plus, j will equal 1, I will equal 2. That's great. Which is really disorienting when a lot of these C++ programs are using the prefix incrementer, which I do not appreciate. Combining dereference and increment in a single expression. And that's where we end today's session. That is, woo! Thank you. So we're going to stop at 4.5. I'll go back over the increment and the decrement next time. Because I guess someone needs to hear it twice. Maybe me. Probably me. But no, it's too warm to do pointers. I'm shutting down. You'll be back, my friend. Every Monday I do C++, and if I don't run out of steam by the night time, I do Unreal. Oh, thank you for the follow. PMudMuck27. That's Muck with a C, not a K. But anyway, this is where we leave it for today's session. Thank you everyone for tuning in. If you tuned in to the live video, thank you for coming to watch the video on demand. If you came to watch the video on demand, don't worry, they're on Twitch and they're all the ones on YouTube, because Twitch only keeps like a week's worth of video content for scrubbers like myself. And as always, I will see you in the next episode.